Most of the students believe soil get hottest at 12 noon, but the truth is different. It does not. And if you understand why, you'll understand soil science better than the 90% of students. So what is the time when soil get it hottest in a day? So I am J.S. Mera and today I am teaching you soil temperature using my own handwritten notes. So this is the most simple practical exam ready and explanation you will hear. Let's start. What is the funda of heat and temperature? Heat is a form of energy. It's energy that flow from hotter body to a cooler body. For example, in soil, when sunlight fall on the soil, solar energy or heat enters into the soil. And what about the temperature? Temperature is the measurement of heat. Temperature tells us how hot or cold something is. It does not tell us how much energy or heat is inside in any object. Only the degree of hotness or coldness there is temperature. For example, in soil, when we put the thermometer in soil, we get reading like this 32 degrees Celsius. There is temperature, there is no energy. Diurnal or daily temperature variation. What is this? Diurnal variations are we have different temperature with the different time. For example, the surface of soil heat in a daytime and cool at night time. So there are the temperature variation with the time. So there is known as the diurnal or daily temperature variation. Let's understand the diurnal temperature variation by diagram. In the in the night time, temperature gets cooled down and then day begins where the temperature start rise and in peak daytime it's a hottest and then again night happens and temperature again cool down, so it's work like this. Night temperature is getting cool, then it's suddenly rising, then daytime happens, it's a peak daytime, then again evening come and then again nights happens, then temperature again get cooled down. So important thing to remember, maximum diurnal variation occur 0 centimeter depth at the soil surface. As we go deeper, then diurnal variation reduces. The reason is that because we know soil surface on 0 centimeter depth is the very closely to the atmosphere. So there is the reason, because if anything would be happen in the atmosphere, then first likely in contact come with soil surface. So there is the reason behind it. Then we know the major changes would be the first on the soil surface on 0 centimeter depth. Depth was temperature changes. 0 centimeter maximum variations happens on 5 centimeter, less comparison to the 0 centimeter. On 10 centimeter, very smaller, then again 25 very smaller, and then on 100 centimeter almost zero. Exact timing. The maximum temperature is reached later as we go deeper. For example, for 1 p.m., maximum temperature is on 0 centimeter. On 3 p.m., it would be on 5 centimeter depth. And on 5 p.m., it would be on 10 centimeter depth. Why it is happening? Because the heat need time to travel downwards. Heat period. Heat period is the time between 10 a.m. to 1 p.m. This is the time when sun hits the soil most intensely. Daily cycle heating was cooling. Soil heat fast but cooler even faster. Cooling lasts longer than the heating. Let's break it in the easiest way with the soil logic. Soil heats fast morning to afternoon. When the sun rises, the soil surface get direct solar radiation. Soil absorbs these heavy heat very quickly because soil has a low specific heat that we all know. This means it does not need much energy to increase its temperature. So even a small amount of sunlight makes soil warm quickly. For example, at 8 a.m., soil is still cool. By 10 to 11 a.m., soil becomes warm very fastly. Heat Heating duration is short, usually from 6 to 2 a.m., exact around 8 hours. Soil cools even faster, evening onward. When the sun sets, no incoming heat, so immediately start losing its heat to the atmosphere. Soil surface has low moisture, it loses heat quickly. Soil radiates heat into the sky through a process called radiation cooling. So, in a result, temperature drop much faster than it increases. Example, at 6 p.m., soil is warmer. By 8 p.m., soil become quickly cool. By midnight, soil can become very cool. By this diagram, you can simply see heating is short and cooling is too long. So, average soil temperature, what is the formula of average soil temperature. This formula is often asked in the examination. So formula is like that: minimum soil temperature plus maximum soil temperature divided by 2. Now the most important part, what affects the soil temperature most? First one, solar radiation, most important. Cloudy region, 30 to 40 radiation. Cloudy region, 30 to 40% radiation can come to the Earth surface. In arid regions, only 75% radiation can come to the soil surface. Only 10% of the radiation actually hits the soil surface. Cloudy area was arid area. What does mean by it? Think of solar radiation as the sunlight energy reaching to the ground. Cloud block the sunlight, so only 30 to 40% of the total sunlight reaches to the soil. Soil receive the less heat, stay cooler for the longer time. Arid region, desert, sky is clear, no clouds, so clearly, so nearly 75% of the sunlight reaches to the soil. Soil receives more heat, become very hot in the daytime. But here is the most important thing that you need to know. Out of all the sunlight that reaches to the soil, only 10% actually hit the soil. This is the funda most important that most of the student miss. Aspect or direction faced. South facing is get more sunlight than the north facing. West facing get more sunlight than the east facing. South facing slopes get more sunlight. There is the reason why, because in India, northern hemisphere, the sun is mostly in the southern sky. So south facing land gets more direct sunlight, more hours of heating, and higher soil temperature. South facing hotter soil. South facing is hotter soil. North facing slopes get less sunlight, so more few hours of sunlight, soil stays cooler. Soil warms slowly because we know soil have water, so water have a high specific heat. And dry soil have warm fastly because of low specific heat. What about the soil compaction? Compacted soil have high thermal conductivity and heats deeper layer very faster. And in case of loose soil, thermal conductivity is low, so slow heating. What about the depth? Greater the depth, smaller the diurnal variation. Annual or yearly temperature variation. Annual variations spreads deeper than the daily variation. Depth is around 80 centimeter to 1 meter, sorry. Depth is around 80 to 1 meter for the annual variation depth. Maximum annual soil temperature is happens in the week of 20 to 23 meteorological week. There is a peak time of May or June. What is the Fourier's law of heat transfer? Heat always flow from hot to cold body, and the rate of heat flow depends on the temperature gradients. That's it. Fourier's law only tells us how fast heat moves. What is the formula? Don't worry, I'll explain you in very simple manner. Formula is Q equals to minus K into dt upon dx, where Q is equals to heat flow that define the heat flow. K define the thermal conductivity, how easily heat moves in the soil. dt upon dx is temperature gradient, temperature difference between the different layer of soil. And negative signs explain us heat always move from the hot to cold body. Practical implications. Now let's apply this in the field. Sowing depth. Deeper soil, more stable temperature, better for the germination. Irrigation. Avoid between the 10 to 1 p.m. Peak heating time, use morning or evening time best for the irrigation. Mulching, reduce daily temperature variations. Fertilizer application, temperature sensitive fertilizer work better when the soil reaches the peak heat at the right depth. Crop planning, sensitive crops should be sown in the soil layers with the stable temperature. For many example we can take like this. Let's say surface temperature goes to the 20 degree at night to 35 degree in the day. Average temperature would be 20 plus 35 divided by 2 equals to 27.5 degrees Celsius. But at 10 centimeter depth, the maximum temperature may be only 30 degrees Celsius. And it occurs at 5 p.m. because we studied the reason already earlier in the previous slides. Use this only in the end. Soil temperature summary, maximum variation on the surface on 0 centimeter. Variation reduces with the depth. Maximum at 0 centimeter on 1 p.m. Maximum at 5 centimeter on 3 p.m. Maximum at 10 centimeter on 5 p.m. Heat period is between 10 a.m. to 1 a.m. Annual variation depth, we measure it around 80 to 100 centimeter. Maximum annual temperature is weak, meteorological week in 22, 23. Solar radiation, biggest factor. Moist, moist soil heats slowly, dry soil heats fast. Compacted, compacted soil conduct heat more. South facing, more heat than north facing. West facing more than east facing. South face more heat than the north facing, and west face more heat than the east facing. Only 10% radiation hit the soil. So that's what I have. So let's wind up the lecture here. These are very small effort of mine.